Hello, thanks for joining the presentation. My name is Li Kunfeng, a PhD candidate in Karlsruhe Institute of Technology. Today, I will talk about our research, Flextile, 3D printable soft actuators for wearable computing. First, I will show you a short introduction. Rapid prototyping and fast manufacturing process are critical drivers for implementing wearable devices. Inspired from this, we proposed an actuator based on the Lorentz law. The first picture shows an overview of Flextile, and the second one shows our driving method, switching 5V DC power on and off. This actuator is fully elastomeric and 3D printable. The core of this actuator is a helical coil made from capillary silver TPU. We made a detailed comparison between our research and related actuators, which shows the Flextile has a most simple manufacturing process and is fully skin applicable and 3D printable. To print the Flextile, only a few steps and efforts are needed. This picture shows the manufacturing process. First is to print a TPU substrate. Second is to print a capillary silver TPU in traces on both sides of the substrate. Third is to cure the trace. The last step is to connect copper wires and the trace together. Moreover, this actuator could be printed in various sizes. We also demonstrate a recipe for making this actuator, which allows others to try their hand in the future. We set up 3 experiments to characterize our actuator. The first picture shows it has a wide scope of working frequency. The second one shows it has a flexible working distance from 1 mm to 7 mm. Also, the actuator is compatible with different magnetic fields. We also explore the user study. The result shows it could generate and convey a clear vibro-tactile sensation to users, and users feel comfortable and not intrusive. We made 2 essential applications. One is a vibration sleeve and the other is a ear-ring-shaped haptic feedback system. However, there remains lots of work to be finished in the future. The factors, for example, density of the coil and the applied current, will influence the performance of the actuator. By changing these factors, the Flextile could be modified to better shapes and better size to fit more promising applications. Thanks for listening.